Good morning 10th standard. Today we will learn how to find out the solution of a quadratic equation. To find out the solution of a quadratic equation means we have to solve the quadratic equation, find out the value of the variable used in the quadratic equation. You have learned how to solve a linear equation in your junior classes. You have also learned how to solve linear equation in two variables. Now we are going to learn how to solve a quadratic equation in one variable. To solve a quadratic equation means we have to find out the value of the variable which will satisfy the quadratic equation. Let's write down the value of variable which satisfies the quadratic equation is called its solution or its root. So what does this mean? So this means if ax square plus bx plus c equals to 0 is a quadratic equation. Now we need to write this, that a, b, c are real numbers and the leading coefficient is not 0. Then and we can find a real number k such that a into k square plus b into k plus c equals to 0. So if we have a quadratic equation and I can find a value for x, now this will be the value for x. If I can find a value for x which when substituted in this equation the value for left hand side is equal to right hand side, then k is called solution or root of quadratic equation. So this means I am able to find out a value which I use in place of x will make the answer equal to 0. And when I say that we are able to find out the value of the variable which makes the answer for this side equal to 0, I am trying to say that we need the 0 of this quadratic polynomial. Now you have learned how to find out the zeros of polynomials, quadratic and cubic, in chapter number 2. Finding out the zeros of a quadratic equation will be exactly like that. Once again we are looking for a value of x which when substituted here, when I find a value of x and I use it on left hand side, then the answer of left hand side equals to 0. And when this happens, when for a polynomial I am able to find out a value which when substituted in the polynomial the answer comes out to be 0, then we say that the value which we substituted is the 0 of the quadratic polynomial. Same thing will be done here. So based on that, let's write a note. The roots of a quadratic equation px equals to 0. If px is a quadratic polynomial, then px equal to 0 will be a quadratic equation. So if we are able to find out the roots of this quadratic equation, these will be same as zeros of quadratic polynomial px. If I had to find out the zeros of this quadratic polynomial, I would take this polynomial equal to 0, solve for the values of the variable, and those values are called zeros. We represented them by alpha and beta in chapter number 2. We are looking for those values, and those values are called the roots or solution of the quadratic equation. There are three methods to find out the roots or solution of a quadratic equation. Methods to solve a quadratic equation. First one is factorization. Second is the method of completing the squares. And then third one is quadratic formula. The second method is not in our syllabus, so this one you can write down that it is not in the syllabus for class 10th. And factorization can be done in two ways: using identities or by splitting the middle term. Quadratic formula is a direct formula which we will learn later in the chapter. Now let us see how do we solve a quadratic equation by factorization. So factorization means we have to split the quadratic polynomial into linear polynomials. Now this will be done only when possible. So you break down your quadratic polynomial or the quadratic equation into linear factors, and then each of those linear factors is taken equal to 0. From there we are able to find out the value of the variable. If you want, you can revise chapter number 2. We have learned how to find out the zeros of a quadratic polynomial. Same thing we will be doing here. It was exercise 2.2. If you look at that exercise, you will know what I am talking about. So this is the first step what you want to do. You want to split your quadratic polynomial into linear polynomials. Then after that you take each linear factor equal to 0, and then from there find the value of variable. So there could be one value or more than one values. Now factorization can be done in two ways. One is using identities, and the second one is by splitting the middle term. Even if you are not able to use any identity, splitting the middle term will work in that case where there is an identity applicable. So I'm going to discuss a couple of examples with you, and then we will start with the exercise. Let us consider this example. Solve 4x square minus 4x plus 1 equals to 0 by factorization. So if this is the equation, this is a quadratic equation. You have to solve this quadratic equation by factorization. If the method to be used is indicated, you will use that specified method. If it is not indicated, then it's up to you. You can use any of the two methods which are in your syllabus. You can solve using factorization, or you can solve using quadratic formula. Quadratic formula is actually a direct formula where you need not worry about this factorization part. You don't have to think of splitting the polynomial into linear factors. You just apply the formula and you will get the answer for x. Here we are going to factorize and then find out the value of x. The first thing I would like to try is whether or not any identity is applicable here. So let me see that. To apply an identity, I want to see two square numbers. So this is a square number, perfect square. This can be written as the square of 2x, and then last term, the constant term, can be written as the square of 1. Looking at the middle term, this can be written as 2 multiplied by this term inside the square, the first term inside the square, into the second term inside the square. So I have a square, I have b square, I have 2ab. A square will be positive, b square will be positive. The product will tell me which identity it is, whether it is a plus b whole square or whether it is a minus b whole square. So what I have done is I have expressed my quadratic polynomial as an identity. The right hand side is still 0. Now this identity will be written in the compact form. This is the expanded form of the identity, a square plus b square minus 2ab. Now I'm going to put it in compact form. To put this identity in compact form, I will be gathering these terms, the ones inside the squares. So 2x and 1 whole squared. In between these two, the sign will be used from the product term. So the product term had a negative sign, so there will be a negative sign here. So this expression actually is a minus b whole square, a being 2x, b is 1. So this can be written as 2x minus 1 into 2x minus 1. Square means a repeated multiplication. So what I have done is, till here, this is the splitting the polynomial into linear factors. So each of the factors that I have obtained, this is a linear factor, this is a linear factor. I'm going to take each of these linear factors equal to 0. So the second step is to take first factor equal to 0 and the second factor equal to 0. From here, find out the value of the variable. So from here, x comes out to be 1 by 2, and solving the second linear factor, x is 1 by 2. So therefore, the roots of the equation given are 1 by 2, 1 by 2, and you can see the two roots are equal. Once again, start by factorizing your quadratic polynomial. Factorization means you have to split that quadratic polynomial into linear polynomials. Further, after you have done that, you have obtained the linear factors, take each linear factor equal to 0. From here, find out the value of variable. Those values will be the roots of the equation. Let's take one more example. I'm taking example number 3. Example number 3 from your textbook. It's on page number 74. So you have been given, find the roots of equation by factorization. The equation is 2x square minus 5x plus 3 equals to 0. This is the quadratic equation given to me. I have to find its root by factorization. So what I'm going to do is I'm going to try whether I can apply any identity or not. I cannot apply an identity here because I don't have perfect squares. Now I move on to the second option, which is splitting the middle term. To split the middle term, there are few steps involved. You are aware of those steps? Still, let's just revise those steps. How do we split the middle term? So for splitting the middle term, I will require two things. I require the product and I require the sum. Purpose is I want to break this middle term minus 5x into two terms, and the coefficients of those two terms will have a special product and a special sum. That's how I have to choose which way minus 5x will be split up, and that will be calculated using the coefficients of the expression here. So the first and the last term, the leading coefficient and the constant term, the leading coefficient, which is 2, the constant, which is 3, both are positive. Their product 2 multiplied by 3 will tell me what product I should have, and the sum should be equal to the middle term's coefficient, means the sum should be -5. So from here, this is the sum I require, and from here I know what product I require. So I have to choose two numbers in such a way that their sum is -5 and the product is 6. You can do this by trial and error, or you can look for the numbers whose product is 6, because there are infinite possibilities to obtain a sum -5. So let's limit those possibilities. Start by looking at the numbers whose product is 6. Always start by looking at the factors of the product you want. We want the product 6. So always look at the factors of 6. So the factors of 6 are 6 into 1, 3 into 2, -6 into -1, -3 into -2. The product should be +6, so it can be obtained using these factors. 6 into 1, 3 into 2, -6 into -1, -3 into -2. All these pairs give me the product 6. Out of these pairs, which pair gives me the sum -5? So this pair gives me the sum -5. -3 -2 will be -5. So this is the pair that I pick. Now I'll be splitting the middle term using -3 and -2. So this means first term stays same, the last term stays as such. Now middle term -5x will be split up into two terms. So in place of 5x -5x, I will have -2x minus 3x. I have actually reordered just to make sure that terms with common factor are together. Right hand side is 0. After you have split your middle term, the second step is to pair up your terms. Earlier I had 3 terms, I have now 4 terms. I will pair up and I will be factorizing these pairs. Factorizing these pairs means I will be looking for common factor in each of these pairs. So in this pair, the common factors are 2 and x. Let us see what's left. Here I'll be left with x minus 1. From here, the common factor will be -3. And inside the bracket, I will have x minus 1. When you take negative factor common, the sign inside the bracket will be changed. Earlier it was +3. Taking a negative factor common, this will become minus. At this step, you want to verify that the binomials are same. If your binomials are not same, means you have made a mistake or you need to make some adjustment here. Once these binomials are same, you can proceed to the next step. This is a product of monomial into binomial. This is a product of a monomial into binomial. From both products, the binomial is common. So let's take the binomial common. I will be left with the monomials. So I'm left with 2x and I'm left with 3 inside the bracket. This is equal to 0. Now you can see this is a linear polynomial, this is a linear polynomial, and I have split up this quadratic polynomial into 2 linear factors. Now we take these linear factors equal to 0 and obtain the value of x. So taking each of these linear factors equal to 0, x minus 1 equals to 0, x will be 1, and the second factor 2x minus 3 equals to 0. From here, the value of x obtained is 3/2. So roots of equation given are 1 and 3/2. Now let us do example number 5 from page number 75. The equation that we have is 3x square minus 2 under root 6 times x plus 2 equals to 0. The first step will be to note down what product and sum I require. So this is for myself. The product I require will be obtained from the first and the last term. So this is 3 and 2 with their signs, positive 3, positive 2. I want the product to be positive 6. Then the sum required. The sum that I require here will be obtained from the middle term. I want a sum equal to minus 2 under root 6. Now this is a special case when we are looking for irrational factors. Your quadratic equation contains an irrational number. So we want to look for irrational factors of the product. Once again, since your quadratic equation contains an irrational number, the sum that you require is an irrational number. So what we want is, we want to look for irrational factors of this product, the product that we want here. So I want the product to be 6. Usually I would write the factors as 6 into 1, 2 into 3, minus 2 into minus 3, minus 6 into minus 1, just like in the previous examples. But these don't work to get a sum which is irrational. So I'm going to write down irrational factors or irrational numbers whose product is 6. One such example will be root 6 into root 6. Both of these are irrational and their product is what I want. Or it could be minus root 6 minus root 6. Their product will also be equal to 6, which I want. Now which of these pairs will give you the sum minus 2 root 6? This one. So this works best. Minus under root 6 minus under root 6. Their product is equal to plus 6. The product is positive 6 and the sum of these two is minus 2 root 6, which suits my condition. Now let us split the middle term using these two. The first term as such, the last term will be as such. Splitting your middle term, minus root 6x minus root 6x. Right hand side is 0. Once you have split up the middle term, you pair up your terms, first and second, third and fourth. Do not use brackets when you pair up. You can underline if you want. Do not use brackets. You will mess up with the signs. So it's better not to use brackets. Just underline to know that which terms you have paired together. After pairing up the terms, it's time to take common factors from the pairs. We will find the common factor from the first pair and we will find the common factor from the second pair. Once again, we are looking at a polynomial in which we have irrational numbers. So I'm going to find irrational factors. I am stressing on this because this is the important part when you have a polynomial or an equation in which there is an irrational number. Always look for irrational factors. Now I'm going to look for irrational factors of 3 and the irrational factors of 2 as well as for root 6. I'm going to write this down, but this is not usually required, so you may skip this step. If you want, you can directly do it in your mind and write down the common factor obtained. So I'm going to split this up. This 3 can be written as root 3 into root 3 into x square. So this is the first term. Then breaking this down, root 2 into root 3, the product will be root 6 into x minus, same way I will split up this, square root of 2 into square root of 3 into x plus the 2 can be split up as root 2 into root 2. And this is equal to 0. So I have written all the terms by breaking them down using their irrational factors. Now you can see from the first pair what will be the common factors, and from the second pair what will be the common factors. If we look at the first pair, the common factors will be root 3 and x. If I look at the second pair, this is my second pair. In this, the common factor is root 2. So from here root 2 will be common, and from here root 3x will be common. Let's write down the common factor, root 3x from these two, and let's see what's left. From here it will be root 3, one root 3 common, another root 3 left. It was x square. I have taken 1x common, so 1x will be left inside. From here I have taken root 3 and x common. I am left with under root 2. Now for the second pair, my common factor is now starting with a negative sign. That means inside the bracket the signs are going to change. The common factor is square root of 2. Let's see what is left in the bracket. Root 2 common, these two left. From here root 2 common and 1 root 2 left. But this term was positive. This term was positive, the last term, but because I have taken a negative common factor, so the sign of this term will change, so that if you multiply, the product becomes positive. Right hand side is 0. Now your binomials match. The binomial in the brackets, they match. Let's take the binomial common and let's see what I'm left with. I'm left with root 3x from this product, and from this product I'm left with root 2 with a minus sign. Now I have obtained linear factors. It is now the time to take each of these linear factors equal to 0 and find out x. Taking first linear factor equal to 0, root 3x will be equal to under root 2, x will be equal to under root 2 by under root 3. You can also write it as 2 by 3 under the root. If you want, you can rationalize the denominator. I am leaving it as such. Taking the second linear factor equal to 0. Because it's same, on solving the answer will be same as the first one. So roots are under the root 2 by 3, under the root 2 by 3. Equal factors or equal roots. Now let us do exercise 4.2, page number 76. Question number 1 is find the roots of the following quadratic equations by factorization. So there are some parts which you would be able to do on your own. So I will be doing just 2 parts from here, and I'm going to do third and fourth part with you. Remaining 3 you will do yourself. So let's take third part. This involves irrational numbers again. I've got root 2x square plus 7x plus 5 under root 2 equals to 0. Be very careful, the variable is not under the root. Only the number 2, the constant, is under the root. Now once again, for myself, I'm going to write down what product and sum I want. The product that I want will be obtained from leading coefficient and the constant term. So root 2 into 5 into root 2. This will be 5 into 2, which is equal to 10. The product of root 2 and root 2 is 2. So I want a product 10 and the sum required is 7. Find the factors of 10 whose sum will be 7. So the factors of 10 will be 10 into 1, sum is not 7. 2 into 5, sum is 7. So let's take these two and split up the middle term. Root 2x square, this can be written as 5x plus 2x plus 5 root 2 equals to 0. If you want, you can write it in different order so that it will be easier to look for common factors. You could do it just the way I have written. Now I'm going to factorize each of the numbers into their irrational factors. So this is root 2 x square, no change here. Writing this as root 5 into root 5 into x. This can be written as root 2 into root 2 into x, and the last one can be written as 5 into root 2 equals to 0. This is completely optional. Now let us find the common factors from the first two terms and from the last two terms. From the first two terms, I can see only x to be common. The numbers are different. There will be no common factor other than x. Once you take x common, what is left here? You are left with under root 2 and x. From here you will be left with just positive 5. Now let us look at the second pair. From these two, root 2 can be taken common. Positive root 2. Positive root 2 means no change of signs inside the bracket. So if I take this common, I am left with these two. So root 2x plus 5 equals to 0. My binomials match. Taking the binomial common, I am left with these two. X plus root 2 equals to 0. Once you have factorized your quadratic polynomial into linear factors, it's time to take each of these linear factors equal to 0 and find out the value of x. So first linear factor equal to 0, second linear factor equal to 0. From here find out the value of x. X comes out to be minus 5 by root 2. From here x comes out to be minus root 2. So the roots are minus 5 by under root 2 and minus root 2. Let us do fourth part of the same question. Fourth part is 2x square minus x plus 1 by 8 equals to 0. Now this contains a fraction. So what I can do is, before I solve, I will take LCM. Take the LCM so you don't have to deal with fractions. Taking the LCM throughout, it will be 8. Over here it's 1, it's 1. So let's solve. This comes out to be 16x square minus 8x plus 1 equals to 0. This 8 will transposed to right hand side, multiplied with 0 on right hand side. This becomes 0. So your equation becomes 16x square minus 8x plus 1 equals to 0. And this can be factorized. You can think of an identity, or you can always split up the middle term. Right now I am able to see the identity which is applicable here. This is the square of 4x. This is the square of 1. First term, the last term, perfect squares. And the middle term is double the product of these two. So this and this, 4x into 1 doubled. The product of the terms inside the squares doubled. 4x, 1, their product doubled. And the middle term is with minus sign, the last term is with plus sign, right hand side is 0. A square, b square, 2ab. 2ab is minus, so what does this become? This can be written as 4x minus 1 whole square. Taking the numbers inside the squares. This was inside a square, this was inside a square. Take 4x, take 1. In between these two, the sign is minus. This sign is from the product term, equal to 0. From here you can factorize and find out the values of x. So we can write 4x minus 1 into 4x minus 1 equals to 0. You could have reached till here by splitting the middle term also. From here we take each of these equal to 0 and find out x. X is 1 by 4. From here x is 1 by 4. So the roots are 1 by 4, 1 by 4. Again we have equal roots. Let us do part 5th. Fifth part, we have 100x square minus 20x plus 1 equals to 0. Looking at what product and what sum we require, the product required will be 100 into 1, 100, and the sum we require will be minus 20. Again, I'm going to start with the factors of 100 so that I can find a pair whose sum is minus 20. Writing down the factors, 100 into 1, or I could write minus 100 into minus 1 because I want the product to be positive. Other possibility is 50 into 2, this will be 100. Minus 50 into minus 2 is also 100. Then 25 into 4, minus 25 into minus 4, this is also 100. 20 into 5 or minus 20 into minus 5, this will also be 100. 10 into 10 is also 100. Minus 10 into minus 10 will also be 100. Now look at which pair gives you a sum minus 20. Out of all these pairs, this pair gives me the sum minus 20. So I'll be splitting my middle term by using minus 10 and minus 10. So this becomes 100x square minus 10x minus 10x plus 1 equals to 0. Middle term split up. Now pairing, common factor from the first two is 10x. In the brackets I'm left with 10x minus 1. From here the common factor, no common factor. So I will take 1 as the common factor and a minus sign. In the brackets I will have 10x minus 1 because of the common factor 1 with a minus sign. This sign changed. From plus 1 it became minus. Equals to 0. Now the binomial is same. Taking it common, I'm left with 10x minus 1 equals to 0. So each of these factors will be taken equal to 0 and obtain the value of x. So from here you can write down that the roots are 1 by 10 and 1 by 10.